Let's begin exercise number 1. We have a small unit connected, just like in the diagram here, and 175 duct, 190 duct. The distances are 12 meters. Because we have a slightly smaller room, we will do a gentle bend and some sharp bends. Here we have a device that you mount on small yachts, sailboats, to see if the wind is blowing. Here we have a larger device to avoid any doubts. Here we have our unit, our setup. Obviously we're on a construction site, the site isn't finished. There's a gap here, but to avoid any suspicion that it's windy here, here you go, we have a windsock.
We have the CWP 360 unit connected. It's running at 40%. How much energy does it consume? Everyone always asks me, how much energy does a unit like this consume?
Here you go. This small unit consumes 14 watts at 40%. And now, what airflow do we have set on this ventilation duct? Dominic, if you could remove that duct, we'll measure it.
Great.
Dominic, I'll give you the camera. And I'll need an anemometer. What does it show us? 88. Good. I am filming without any cuts, so there's no suspicion that I'm editing anything out. And now let's go to our ducts. One is a 90 and the other is a 75. Here I have this set up without any cuts. Obviously there's no breeze that would affect us. First we'll lay the 90 duct. Dominic, if you could take the camera, because now I'm going to have a problem. Here you go. We have a 90 duct, 12 meters. How much is it so that it's visible? It can't cover the sensor. Wait.
Did you turn off the camera, Dominic? No, the camera is on. This is blocking the sensor like this, so that we can see.
You can shine a flashlight so it's visible, because we can't see it here, but I know it's 45. Here you go, 45 cubic meters per hour. This is the 90 duct. Now for the 75th. How much is it? Dominic, shine the light. It's 25. Here you go, 75, 25.
90 again, just to be sure. Shine the light, Dominic.
It's 45, so a coefficient of 1.8. Look, this is how these ducts are arranged. Here we have a minimal bend, not a significant one. Here too. Now we will do it like all the greatest specialists. That is adjustments with these rounded bends. See? With the 75s we had 25s, so we will bend it. Here you are. Our setup looks the same, but we have a bigger bend. Let's see what happens with the measurement. It was 25. What happens? Because everyone says that you compensate with bends. Here we go, 24, 25, basically the same. There's the bend. What's this bend for? It may make the system quieter.
Maybe, not always. Let's do the same with the 90s. Look, there are no winds here, everything is okay. Let's do the same with the 90 duct. We also made one bend. What happens? Here you go. Before it was 45, now it's 44, 46. Basically, this bend didn't change anything. Now, Paweł, I would ask you to make a very sharp bend.
A sharp one.
Like that, and let's see what happens.
At the 90 duct, well, I am quite shocked. I was expecting something else. It's basically the same. Squeeze it even harder.
Yeah, squeeze it harder. The 90 tends to be difficult to bend. We'll see. Basically, it shows us the same thing. I can hardly believe it, but all right.
Let's do the same with the 75.
First, squeeze it like some people do. With the 75s, it was 25. So let's see what happens. Now,
How much is it for the 75? Just a moment.
it's also 25. Let's see the 90 now. Once we bent it like this, I don't understand this. It's 43.
I am shocked because it always turned out to be half as much, and we have a professional anemometer. We've got the mesh, we've got everything. It should be a little more, but apparently the unit compensates for it with the fan. I know what happened now. Here we have a special little fan which has an exceptionally high static pressure, and there are two circuits. So this unit just pressed a bit on these parameters. These are EBM PAPST fans with EC motors, and if there were more circuits here, 5 or 6 or 10, and we were bending, then it would be noticeable. With these two, it's not a great experiment. I would have to do it like I did last time on the regular motor, then it was immediately visible, but this way the unit compensates. But fine, everyone says not to adjust the flow with the dampers, that it's a mistake, that everyone adjusts with duct length by compensating. We will try to set it up. It's 43 here. We will try to set it first on the diffuser. Could you hand me the sound level meter?
Alright, if I don't make it in time, then turn it.
How much is it now? 40 decibels. Let's adjust it because
Sometimes you say the system is loud.
Hold on, we'll tighten it. I'll try to set it on both the diffuser and the damper.
Birds are singing here too. Let's not measure this now because it will be nonsense. We'd have to do it in a lab, but look, we tightened the diffuser, we turned it down to 0.
Let's say let's say to 5 or 5.5. And now everyone says you adjust with diffusers. The stream is adjusted with diffusers, and this is adjusted with the foam. We'll do the same with our foam.
See, it's lifting here. We'll do the same thing with the foam, and there we can adjust the stream, the shape of that airflow.
Similar values. The issue is adjusting it, and now look, we have the flow set at 7 or 8 cubic meters per hour, and here by adjusting we regulate the shape of our stream, and that's what the diffuser is for. Turning down with the diffuser and turning down with the damper are the same, but here I can make it quieter and set the direction and shape of the airstream.
Unfortunately, I can't measure the sound here as it would have to be done in an anechoic chamber. It's impossible to do at home or on a construction site.